Hi, in the last video I said that the array modifier was bad and I showed you why it's probably not the best solution for certain situations. So this video is called Array Modifier Good, and I'm going to show you why and how you can make use of the array modifier in geometry nodes. So let's jump right in. Alright, here we are back in Blender 2.93 Alpha, and of course with geometry nodes, first thing we always need is geometry. So how about we go to the center here, we shift a plane, go into edit mode, merge everything at the center. So now we have exactly one vertex, which you can see over here. Now on this object we're going to add an array modifier, and probably let me do this. Go to constant offset and go 1 meter. So now we have 2. And if I set this to 100, now we get this line of vertices, 100 vertices, right? And since we have a constant offset of 1 meter, we know that this one is at position 0 and this one is at position 1, 2, 3, and so on and so forth. Now we can't really see anything, so let's also go in here, add an icosphere, maybe hide it, we know it's there, and we go back to this object. Down here we go to geometry nodes, create a new node tree, and zoom in a little. So now we have an array modifier and the geometry nodes modifier coming after the array modifier. And now of course we can go to point instance, maybe all the way back here, plug in our icosphere, and now we have 100 icospheres. We can also do point scale because the icospheres are a bit big. Switch this to vector and do maybe 0.3, 0.4, something like that. So now we can see that we have 100 points all in a row, all done with just an array modifier and the geometry nodes, right? But that's just one line. In the last video we had a grid. Can we do it? Of course. Just plug in another array modifier. Of course we have to be above the geometry nodes. And then we go constant offset 0 on the x, but 1 on the y. And now we have a grid. Cool. Can we do 3 dimensions like in the last video? Of course. Just add another array modifier. Plug that in again before geometry nodes. We're gonna do constant offset 0 on the x, but 1 on the c. And now we have this 3-dimensional grid full of icospheres. It's kind of a lot, so let's just do 20 by 20 by 20 so that the viewport is still fast and snappy. And now we lost our geometry nodes input or node tree down here, and all you have to do is go here and activate this modifier to get the node tree back. So this is a very simple node tree, and yes, the array modifier is good for this kind of stuff because you can generate a geometry, which you need in geometry nodes. And if all the geometry you have is just a single vertex, then the array modifier is perfect for that. So if you want a 1 or 2 or 3-dimensional grid, a very simple grid, you don't need animation nodes to create the grid. You can do it with array modifiers. Now it's up to you if you like the animation nodes version better that I showed in the last video, where you have a real grid node that you can set and you can define the sizes and all of that. Or if you like this version better with the 3 array modifiers. I personally kind of like the animation nodes version, where you have a node and you can set your grid on a single node and you don't have to go in here into the modifiers. I wonder though if maybe sometime in the future they're gonna put generator nodes into geometry nodes, because simple things like grids, which are like used a lot, needed a lot, maybe we could just have a point generator grid, point generator something, circle, Maybe. We'll see. Until then, you can either do the geometry nodes, the animation nodes thing with the grid, and then use geometry nodes after that, or you do the array modifiers to get this kind of a cube filled with points. So this is the first thing we can do. We can use the GOOD array modifiers to generate grids. Now let me get rid of those two, so we're back to just one line. Go in here, maybe set this to 100 again, and now we know that this one is at position 0, this one is at position 1, 2, 3, because we have this constant offset of 1 meter, right? So how can we do something a little bit more interesting in geometry nodes that we can do in animation nodes using loops in animation nodes? We don't have loops in geometry nodes. Why would we want a loop? Because the loop has an index. So if you have 100 nodes or 100 points in 3D space, and you can loop through those 100 points, you get the index, and you can use that index for maybe a mathematical function, right? Now, in animation nodes, we have the loop nodes, and it has the index. But here we don't. But think about it. We do have loops in geometry nodes. In fact, every single node in here is a loop, right? This is a loop. It loops over every single point of the geometry and does something with it. It scales the point. This is a loop. There's a loop inside of this node. It visits every point and instances the icosphere to that point. If we look at the attribute nodes, let's just pick one, attribute math. This is a loop. It does something on each point of the geometry that you plug in here. So this loops through all of the geometry. If somebody says, hey, we don't have loops in geometry nodes, we can't do anything cool. That's not quite right. Every node is a loop. So how can we use that? Well, think about it. If, for example, we have an attribute separate XYZ node, and we can use the attribute vector position. Oh, by the way, this is new. I think I downloaded Blender yesterday, the latest version, 2.93 alpha. You now get sort of like a selection box of all the possible attributes, which is awesome, because now I can just simply click on position. If I separate the position of each point here into its X, Y, and Z components, then X is actually the index, right? Because we know that the array modifier uses 1 meter. So the first one is at 0, and the second one is at 1, 2, 3, 4. So if I plug my X position of the point into a new attribute called I for index, now I have the index in an attribute. So now each point knows at which position in the loop it is. And what can we do with that? Well, we can, for example, use it for a math function, attribute math. Maybe we want to do something very easy, sine, like those sine waves. We take our index I and we plug it into a new attribute called S. So now we have a new attribute S, which is the result of the sine function. And what can we do with it? Well, how about we attribute combine XYZ. We're gonna put the I that we have. So we want an attribute on the X, which is I, so that they stay in their positions here along the X-axis. And on the Y-axis, we take the attribute, our sine function. And the result of our attribute combine here should be the position. And then we have the sine wave on our line of dots here. Now we need a little bit more math, right? So this is the function that makes everything happen. But we have to do some stuff, or we can do some stuff before we hand it off to the math function or any other complicated function that you can come up with. You can create sort of a complicated node tree in a node group that you plug in here. So what can we do? Well, how about we plug in another attribute math in here, and we do something with our I attribute. Right, so we take the I, the result should be the I, and we want multiply by a float. So if we multiply by 1, we get our original thing. If we multiply by something, or if I slide this over to the left, you can see I'm sort of compressing my array of 100 dots into a smaller space. So if you think about it, if you have like an analog digital converter or something like that, you get more samples. So this is our factor now to get more samples along the sine wave. Maybe let's set it to 0.2. Then also we can plug in another node here just to show, and we set this to add. And this lets us slide the offset, right? So multiply is shrink it or stretch it. Add is always move it along the x-axis in this case, because we're moving the I variable. So here we can slide it. Probably don't need this node, but we can do that. And after our sine wave here, let me move this over to the side a little. After, we can also do stuff. Again, we can take a math node, and in this case we want to mess around with the S. So we want to change S and set S. And you can already see here we can set the amplitude. Okay, by multiplying the sine result. The sine is always between -1 and +1. So by multiplying it, we can increase or decrease the amplitude. Cool. Now, how can we change the frequency? Well, we are going to have to mess around with the I, because the I is going on the x-axis, which is the frequency. So how about we multiply the I with a certain factor, and there you go. This is the frequency, this is the amplitude, this one here is sort of the sampling frequency, and this one here is the offset. Of course, this is just a very simple sine function here, but like I said, you can do crazy stuff with this now, because you now have an index which you can loop or think as if it were a loop, right? Just because we took the position, and we know that we are using 1 meter on the array modifier, which gives us an index. Now, how about we want to make a circle? Can we do that? Of course we can. All we need is sine and cosine. Cosine is the other one, right? So sine, cosine, plug that in here. And here we take I, our index, and we assign it to a new attribute C for cosine. So now in here, coming out of here, we have a sine in S, cosine in C. Maybe let's clean this up a little, or I don't know, we don't need this this I anymore, right? We want to multiply the C and result in the C, and we're gonna use the C for the X. I have to click here, and the cosine, the sine, or the other way around, doesn't matter, and we get a circle, perfect circle. And here we can stretch it along the X, and here we can stretch it along the Y. Now, why do we get these sort of groups? That's because we have way too many dots in our array here. So we get this, right? Or we go back here and increase our sampling frequency with our first multiply. And we crank up the array here to get back to a circle. Now we have a nice looking circle. Am I in top view? Yes. So now here, this one stretches along the X and this one stretches along the Y. Your videos are pieces of art, wall art. Print My Video extracts up to 20,000 frames from your video's timeline, compresses, aligns and enhances them, and even overlays the audio waveform, and carefully bends everything into a perfect circle. After they manually optimize and quality check each artwork, you can either download a high-resolution image file to print at home or at your favorite print shop, or they can hand the picture off to a professional printer near you for perfect prints with high-quality materials. Print My Video have printing partners all over the world to cut down on shipping costs, be environmentally friendly, and support local businesses. Any video can be printed and preserved for eternity. Your wedding, the best vacation ever, your favorite music video, anything goes. Head over to printmy.video and hang your own vibrant, beautiful, one-of-a-kind video print on the wall. Use the coupon code CHRISP at checkout to get 10% off. Now let's do something I haven't tried before, but this is exciting. We want to see if we can do it. In one of my tutorials about animation nodes, I think it's in one of the beginners series somewhere, I have this two-dimensional grid of objects, and then I have the sine wave going in one direction, the cosine going in the other direction to create sort of like a wavy grid of objects, or like the surface of water. I don't know. So let's take this idea that we have here into sort of 2 or 3 dimensions, right? So how do we get started? Well, let's see. Maybe we should just start with, let's do, I don't know. Let's first of all, add another array modifier. We're gonna have to put that on top here. On the first one, we are going on the X. So on this one, we have to go on the Y to get that two-dimensional grid. We're just gonna do 100 here and 100 here, so we know what we have. Then we get into geometry nodes. And what we want to do here is none of this here. So we take the position, we take the X, let's just plug this into X, plug the Y into a Y attribute. So now everything is empty, of course. Now at the end here, if we just mute this for now, at the end we want X in the X, Y in the Y again, and a C probably. Why isn't this X? X. Right, so we have this grid. Cool. Okay. Very nice. It's quite big actually, but that's okay. And the C is going to be the result of our calculation. So let's just plug in our attribute C that we now have to sort of in here. You know what? I'm just going to delete this because it's confusing. Generate, right? So we're gonna take an attribute math, set it to sine, take the X position for the sine and result that into C, maybe? Yeah? Okay, so we already have sine going along the X. Now, of course, we want to change the frequency here. So we're gonna do attribute math. I'm gonna take our X, result in X, multiply by a float, and then we can stretch this out a little or bring it in a little. We also need that stuff in front of the sign. Another multiply, but here we're gonna also mess with the X, yeah, okay. So let's do this and then stretch it out like this to make it look nice. Okay, so here I'm increasing the sampling frequency, here I'm decreasing the sine frequency. So we already have the X done. Now let's do the same thing with the Y. We can do that just after. So we're gonna need a cosine. Where is it? Cosine. And here we're not taking the X, we're taking the Y. and we're gonna result in C, which completely destroys everything we did in front here. So maybe we're gonna put this not into C, but into S, and the cosine we put into cosine, and then we plug it all in back here with another attribute math where we what shall we do? Shall we add sine and cosine? I guess you have to click it here. You can just type and result in the C, and then we have this. But just like with the how do I order this a little bit better here? So this is cosine, add after cosine. This is all the sine stuff here. Let's just put it a little bit together like this. And then I need another factor going on the y here. So y and result in y. Ooh, and it already looks kind of cool. So let's do this maybe. And then, oh, this is the final add. Right. So, and back here we're gonna multiply the C, the cosine, and result in cosine. So we have the amplitude here. Let's do something like this. And then we have waves going this way, and we have waves going this way. And so basically we have one node tree here. We don't have loops like in animation nodes, but we can still do the same thing like in that other tutorial that I showed. Okay, now there's one thing I want to mention here with geometry nodes, because I'm still not getting used to it. And that's the fact that if you look at this node tree, you have no idea what's happening. They're all blue nodes because they're attribute nodes. It's all just geometry piping through, and you have to follow each node and think about what's happening to know what's happening, because it's really not obvious, right? If I take, for example, a shader node tree, let's look at maybe this one. Go over to the shader editor. Here, let's look at this big. We know that the principal node is a shader node, and on top we have the colors. In the middle we have sort of the settings like roughness and all of that. At the bottom we have the normals. So we know that anything coming up in at the top is going to be colors, right? So just looking at this node tree, we know that all of this, which is coming in at the color here, the color input here, is somehow responsible for creating colors. Then we have different nodes, and they have different colors, and they have different inputs and outputs, and the input and output sockets have different colors because they have different data types. So it becomes very easy to read what's happening here because of those differences. Here we have a vector purple, and the purple vector node has a purple socket which goes into a purple vector socket, right? So looking at this, or if you have something down here, maybe like a texture, noise texture, and you plug that into a vector bump node, and you plug the color into the height, and you plug that into the normal. Just if you look at this, even if you don't see any of the values or settings, you know, okay, this is color, this is for bump mapping or something vector related, or if it goes in here with a displacement node in between, you know it's displacement. So this is very easy to read. Now let's go back to geometry nodes and look at this. And this is impossible to read. It all looks the same. It's all just one long spaghetti of the same node doing something, and you have no idea what it does unless you start at the beginning and you think about, okay, here we are ripping the position apart into x, y. Here we are multiplying the x with a float, and the result is the same x. And then if you go through this, then of course you know what's happening. But the overall the image or the feel that you get when you look at this is very confusing. I don't know how about you, but this is I'm still struggling with this, and I don't know if there is a way to do this differently, to visualize this differently, to make the node tree readable. Especially if I give you this node tree now and you download it from my Patreon, and I'm not telling you this, what I'm telling you here in this tutorial, you don't know what's happening. You can start playing around with the values, and then maybe you know what each node is good for, right? Now, one cool thing that Geometry Nodes introduces is something I haven't talked about in any tutorial before, and that is this little tiny socket here. And this is really quite awesome, because just like with material node groups, you can pipe certain attributes out here into the group input node, and then they become available over here. So for example, let's say, what is this? This is our X sample frequency. Maybe that's not very interesting. This is our Y. No, let's take this one. That's the X frequency, right? The X frequency. So I can take this, plug it in here, and look at that. It becomes available over here. We can even go in here, node, go to the B node, give it a name, call it X frequency, and then you have a nice label over here. And now you don't have to go back into the node tree to change something. So maybe if you're in the shader editor and you're doing materials, you still have that X frequency out here, and you can still change it over here. And of course, you can go back into Geometry Nodes and you can pipe other options, like for example, the Y frequency, also out here. Again, name it Y frequency, and then you have this slider here, and you can change the Y frequency of the cosine. Am I doing this right? It doesn't matter. You get the idea. You can pipe stuff out here. And now when I saw this the first time, that just like with a node group, where you can do stuff like that, and let me show you. I'm sure you've seen it before, but just to be sort of feature complete here in this tutorial, I'm sure I have some sort of material in here where I have a node group. Let me see. Yep, so this is a node group, metallic car paint. It has inputs and it has one output. And if you go into this node group with tab, then this is actually the node group, and it has this group input. It has this group output. And whatever you plug in here you can also see this empty new socket. And whenever you want to pipe something or make an attribute available for the user of the node group, you just plug it in here. It becomes a new input, and all of the inputs that are here are also here. All of the outputs that are here, you can plug in more. As you can see, there's this empty socket here, become available here. So this is the node group that we've had in the Blender node groups or node trees for a very long time. But now Geometry Nodes takes this one step further and makes attributes available to the user of the geometry node tree out here. And when I saw that, I thought, first thing I thought was, well, why not make this feature available for shader node trees as well? Let me know in the comments down below if you think this is a good idea. That was the first thing I thought, why doesn't the shader node tree have an input group where I can say, okay, you know, this value here, where I already made a value node so that I have one place to change this value. Why can't I make this available on the outside here, maybe somewhere in the material tab, so that when I'm on this cutting board material, maybe in here somewhere down here, I have those values available, those sliders, so that I don't have to jump into the node editor to change it. What do you think? Let me know in the comments down below. I think this would be awesome. And also, since we're at it and I'm complaining about or I'm thinking about things that could be better, please somebody make it so that all of these parameters here have input sockets so that we can pipe them into group inputs and make them available to the outside world, to the users. I don't know why none of these options here have input sockets. And I'm talking about, of course, the compositor nodes here. The compositor is one of my favorite tools in Blender, but it's very hard to make reusable node groups for other people maybe to use, or for yourself to use maybe as an asset in the asset browser, just because like most of the inputs in compositor nodes are not available through input sockets. I cannot change this X. I have to go in here and change it on the node. This is very annoying. All right, enough. I'm done thinking about cool things that Blender should have and that I wish were there. That's it for this tutorial. I hope you learned something new. And if you did, please give the video a thumbs up. Consider subscribing to the channel. I'm all about Blender here. If you're interested in animation nodes, check out all the other tutorials here on my channel. It's all free. And animation nodes is cool. I keep getting the question, do you think that geometry nodes will replace animation nodes? Maybe sometime, long time in the future, but always think about the name already tells you geometry nodes is about geometry, and animation nodes is so much more. You can do everything with animation nodes. You can script things in animation nodes regarding colors and materials and actions and all sorts of things, not just geometry. So I do think we will see some sort of generators maybe in the future, so we don't have to do free array modifiers and all that. Maybe we get a grid generator, a circle generator, something. But I think there will always be a place for add-ons like animation nodes. Okay, enough said. Thanks for watching. Crispy out.